This is AP Precalculus. I am Mr. Sindel. Let's jump into the first set of notes. First of all, we have a function that maps between input and output values such that we have each and every input value is mapped onto exactly one and only one output value. So what does that mean? Graphically, I think is the easiest way to see this. If I have some sort of graph and I have some weird, function that goes woo, 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 like this, I'm telling you, hey, go to any sort of x coordinate that you want and tell me what the height or tell me what the y coordinate is. So I say, hey, you go there. Oh, I know where to go. I go there. So this part is a function. However, if I come back over here and I say, hey, go right here, it's confusing. What height do I go to? Here, here, here? It's not clear because there are more than one output value. There's more than one height. So we're trying to say, hey, only one height is allowed. So this fails the vertical line test that you learned from Algebra 1 or from Math 1, whatever system you're doing. However, this is not necessarily true for AP Precalculus because eventually we're going to be learning about polar functions. Polar functions are super cool because if you have a polar function, you can have a function that looks like this. And this obviously fails the vertical line test, but this is still a function. So we need to change our definition a little bit. And we need to say that each input has one output and exactly one output and no more. It doesn't have two outputs. Whenever I tell you go here, it's not ambiguous as to where to go. You know exactly where to go. There's only one place to go. So all of those input values are in this word starting with a capital D, domain. All the inputs are in the domain and all the outputs are in the range. Just a good little review of those words. And are these independent or dependent? Well, domain, you can choose whatever you want to be. It doesn't depend on anything. Therefore, we say that's the independent variable. However, if we choose that variable, we know exactly where to go to. We have to go to this one. This one depends on what we chose. This is called the dependent variable. Notice that this is mostly called the x and this is called the y. Do we say? I'm just going to put x right here next to the domain. This is the x and the range is all the values of y. We'll be talking about that in a little bit. So we know that a function is positive if it's above the x-axis. Draw a picture with me. If I have a graph, and there's my x and y axis, not very straight, but whatever. If I have some function doing weird things and I'm only above the x-axis, I'm on the top two quadrants, quadrant number 1, quadrant number 2. If I'm only in these two quadrants and never in the bottom quadrant 3 nor quadrant 4, then this is a positive function. And vice versa, if I have a set of axes where the function only lives in quadrant 3 and quadrant 4 down here, this function down here is a negative function because it never crosses the x-axis to come up here where we are positive. All right, just be warned that throughout this course, we are going to be converting between a graph into an equation, a graph to a table, a graph to a verbal expression, and vice versa, right? An equation can go to a graph, a table, a vertical. We need to be able to convert between all of these multiple representations of mathematics. Be ready. All right, so example number 1, we have this vase, and this vase is not a cylinder. If we had a cylindrical vase where I have just I'm obviously very artistic right here. If I had a cylindrical vase and I was pouring water in a constant rate, then my graph would look like this. I would be going up at a constant rate. It's slowly trickling in, going up, going up, going up, going up. That's boring. We're doing this way cooler example where we have a vase that is not a cylinder. When I start pouring it in, it's going to start slowing down. Notice because I have a larger and larger radius or a larger diameter, a larger amount of water that needs to fill this space. You can say that because the diameter is increasing, we need to make sure that we are slowing down. And eventually, when the water gets to the very top, I do have a water bottle where the top is a little bit smaller. And I have to be really careful because when my water bottle is filled up at a constant rate, at the very top, it accelerates and I have to be careful I don't overfill the water. So it is up to you. Which of these 4 graphs could represent the rate of change or the height of the water being poured in at a constant rate into our vase? And I already gave you a hint. It's not this one because it's not a cylinder. All right, well, you've either thought about it or you've given up and you just want the answer. Which of these answers is it? Well, it's not A because it's not a cylinder. It will eventually slow down as the diameter gets bigger and bigger. It could be B because it's kind of going up at like these variable rates. C is kind of not making sense, right? Because my height is going up and then all of a sudden my height over here is going down. If my height is going down, that means water is somehow leaving my vase. Maybe I have a crack in my vase and the water is leaking out. That doesn't make sense in the context of the question. I'm not like spilling water back out. I can't go back down in sort of the height. So like circle right there, that means water is coming out. That's a no-no. So it's not C, it's not A. And D, it has like some curvature going on. So it's between B and D at this point. Well, let's analyze what's going on. I talked to you already about the top of this vase. At the top of this vase, I am accelerating really fast, and I want to make sure the water doesn't come out because my diameter has gone down so fast. I'm going faster and faster. So towards the end of my graph, I should be accelerating. I should be going really, really fast. And notice that this slope here is going slower and slower and slower, where this slope is getting bigger and bigger and bigger. And I guess it's almost the same. It's almost a line at that point. But I would say that this one is accelerating faster than this one at the very end, matching that tip. So I immediately go with option D. And notice at the beginning of the graph, you can use that as well. At the beginning of the graph, it should be starting to slow down. This one was really slow to begin with and starts speeding up and speeding up and speeding up and getting a higher and higher slope, whereas this one starts speeding up really quickly at the very beginning, which also means that the beginning and the end are correct, and the beginning of B and beginning or end of D or end of B, these beginning and ends are incorrect for this graph, so you can cross off that one as well. All right, so here are some words coming your way. There's a bunch of vocabulary in this class, and we need to be able to distinguish between increasing versus decreasing, concave up versus concave down. So if you're taking this class, if you're taking an AP class, I assume you are destined for either a 2-year or a 4-year university. In those universities, you will have a textbook where you're giving this. I call it gobbledygook, reference to Harry Potter, but it's really hard to decide what does this mean? So here's how I'm going to interpret it, and then I'm going to give you a final definition that I'm going to be using more often in my class. But we do need to know how to decipher formalized mathematics. So A and B, what are those? Well, I see that A and B are being used as inputs over here. So this is kind of like an x-coordinate. You have x-coordinate of an A, you have an x-coordinate of a B. And I notice that A is less than B, and here's how I choose to interpret that. If A is less than, that means that A over here is on the left. And B over here, because it's greater, that one's going to be on the right. Notice I'm not using up and down because the x-axis moves to the right and it moves to the left. So I have a point, maybe it's -2 on the left, maybe A is -2, and I have a point, maybe 4, B is 4 on the right. And it's saying, hey, if you do f of that value, technically this means I'm plugging in my x variable into a function that has an output of a y. So it's saying the y value corresponding to A. Again, that's still a little bit too complex. Usually what I say is the height. The height and the y value are kind of interchangeable. I'm going to say the height at A and the height at B. It says, well, the height at A is less than the height at B. And that makes sense. Remember, I'm going to pretend here. I'm going to pretend that A is actually -2. I'm going to pretend that B is +4. You don't need to write this down in your notes, but let's pretend that that's the case. That means that the height at -2 and the height at +4, let's see what those are. The height at -2 is right there. The height at +4 is right there. Well, look at this. The height at -2 is all the way down here at a height of -1. The height at 4 is up here at a height of 3. This height of 3 beats a height of -1, which makes sense. That's what it means to be increasing as a formal definition. That's all very valuable, but let me give you an even bigger definition. In English and in almost every language, we read from left to the right. If we make that assumption for all of these definitions, then as we move from the left to the right, our graph is moving up. I like this definition because it's simple and it's still valuable. The formal definition is very, very specific. It's used in textbooks, and there is a reason later on in mathematics when you hit university level why you need specificity, because then people start playing devil's advocate and punching holes in your theorem of like, what does it really mean to move up? Well, it's the y variables technically. So let's move on to decreasing. I'm going to use my simple definition. I'm not going to decipher all of this terminology. I'm going to say as we move from the left to the right direction, the way that we read, I'm going to be going down. In terms of the height, I should say that the height is going up and the height is going down. Concavity. Concavity is the curvature of the graph. Notice that when my rate of change is increasing versus my rate of change decreasing, that will affect these types of graph. So the way that I've always taught it is think of an airplane. I'm going to do a very terrible attempt at drawing an airplane. There's one wing, and then it's going to come back over here. There's another wing, and I don't know, like some sort of triangle type thing. As an airplane, you have a choice. Do you want to try to pull up and save your passengers, or do you want to try to accelerate down into the ground using gravity and crash into the ground? Well, hopefully you're trying to pull up. You're having this force that's pulling you up. You're pulling up. If you're ever trying to pull up, that means that you're concave up. Sometimes I have like an entire group of girls and they want it to be a little bit more cutesy. So here's your cutesy definition as well. If you see anything that's a smiley face, that's concave up. And similarly, for concave down, I usually think of this as a cannonball. If you have a cannon down here, it's a very impressive cannon, and you shoot a cannonball out of the cannon, it has a force that's pulling it down known as gravity. It is being constantly pulled down. It's constantly being pulled down, and eventually it does start heading in that direction down. If it's being pulled down, it is concave down. Again, if we want more of a cutesy definition, if it's a rainbow, it's going to be concave down. And let's do a little pot of gold for the very bottom of the rainbow. It's filled with pots of gold, and they're shining very brilliantly. Rainbow, concave down. Smiley face, concave up. It's the curvature of the graph. So it's really important to be able to notice when these things happen. Where is the graph concave? Where is the graph increasing? Where is the graph decreasing? You never talk about heights because that can be confusing. I know it's very tempting to say, well, I can see, Mr. Sindel, this thing is increasing from the height of -2 to a height of +3. That becomes confusing really quickly. Watch this. Where is this function concave up? Well, it's concave up between here and here. It's between +3 and +3 also. We do not refer to y variables to talk about where these events happen. We talk about x variables. Between the x coordinate of -3 to this x coordinate of 4, we are increasing, and technically because we have arrows, it's increasing everywhere. And same thing for the concave up. We talked about the x variables. Between -4 and between +4, this is concave up. Whenever we refer to behavior, the way that we describe that is with x variables, and then we do some sort of intervals. Let's see how to do that. So in example number 2, we are asked, where is this graph increasing? Again, my definition of increasing is height going up. Where is the height going up? And most, like even kindergartners can say well, it's going up between here and here, and they can just point it out. You should be able to analyze this as well. It's going up there, and it's going up there. Over here on this range, it's going down, therefore it's decreasing on this interval. Now, how do we describe that? We need an answer after all. We want to say the x variables. There's 2 ways to do this. You can do interval notation, my favorite, or you can do inequality notation. This is inequality notation. Inequality has inequalities. It has like less than or greater than, less than or equal to, greater than or equal to. I am going to do interval notation for this one. If you want me to convert to inequality notation, I can do that one as well. I want to say everywhere between here and here, because I'm talking about the x-axis. I always talk about x-axis, never the y-axis. Everything on the x-axis between here and here, this green line is going up. So it's between I was about to say -1. What am I doing? Between 0, this is the x coordinate of 0, all the way to this x coordinate of 3. And then the question is, should it be a parenthesis or should it be a square bracket? Well, you can't be increasing at a single point. You can't say, well, I can ignore the rest of that line, and at that one point, I'm increasing. You need at least 2 points to see that you're increasing. So for that reason, I'm going to do a parenthesis here. But here's the thing. In an AP class, it doesn't matter. This is more of an AP multiple choice type question, and they're never going to be like, well, is it 0 to 3 like this, or is it 0 to 3 like this? This question will not appear on an AP test. They will not be nitty-gritty details of parentheses versus square brackets in the multiple choice, so I'm not going to cover it that thoroughly, but the correct answer is with parentheses and not square brackets. Now, if I wanted to convert this into inequality notation as opposed to the interval notation that I've chosen, I could say, hey, my x values happen between 0 and 3. Either one of those is fine, except for the fact that we've missed this other interval. We need to say this interval as well, between 7 and between 9. So I have to say union between 7 and 9 in parentheses in this case, and I can say this x is between 7 and 9. Do you need to have a union and be fancy like me? No, you could say the word and. I don't care. Just say that these 2 intervals and you're good enough for me. All right, so in this class, you are going to see this word over and over and over again. It's like it's with us forever. In every single unit, you will see the words rate of change. Please, every single time that you see rate of change with me, cross it out and change it to the word slope. Every single time, rate of change it to the word slope. A lot of people want to say it's ROC. Sometimes you'll see that. ROC is rate of change. But again, if you see this ROC, cross it off. That is the word slope. It is much easier for students to understand slope than all of these words rate of change. So, and we have to be super duper careful. Watch how close these definitions are. I can say F is increasing, the rate of change of F is increasing. These mean completely different things. This is saying rate of change is slope. If it's just F, F by itself is just height. Remember back when I said, I don't know, did I say? I said over here, F of -2 is the height at -2. Whenever you see an F or a letter, a function notation, that is talking about heights. So this one is saying heights are increasing. This one is saying slopes are increasing. They look almost identical, so be very, very careful. So looking at an analysis, you can say that all of this graph, this F, all of these, and whenever you see F, you change it to the word height, right? Whenever you see F, you can say the heights are positive because we're above the x-axis. You can say F is decreasing, which means that our heights is going down. And the rate of change, cross this off and say slope is increasing because we're trying to pull our airplane up. We're pulling the airplane up. We're pulling the airplane up. Or you can extend this. It doesn't actually extend like that, guys. It's actually an asymptote that goes forever and ever this way. But I'm going to do this make-believe and extend this and make it into a giant smiley face. A giant smiley face here means we are concave up. Concave up. Okay, you need to know these definitions. Here we go. Let's try another one. G, every single time you see a letter, just swap that out for the word height. Height. The height is negative because we're underneath the x-axis. Below the x-axis. G, okay, I see a letter. I'm going to cross it off. I'm going to change it to the word height. The height is increasing. Increasing means you're going up. Well, look at this. The height was here, the height was here, the height was here, the height was here, the height was here. The height is indeed going up. The height is increasing. It's going up. And finally, the rate of change. You see those words, you cross it off. You change it to the word slope. What's going on with slope? The slope is decreasing. It was a really, really extremely high slope, almost to the point where it's infinite, a vertical line. And that slope progressively gets less of a slope, less of a slope, less of a slope, almost until that slope is zero. The height is being pulled down. You can say it's pulling down. It's a cannonball. It's being pulled down. It's being pulled down. And I'm going to fictionalize and pretend, oh, it's a rainbow. You can see the rainbow in the pot of gold. If it's a rainbow, it's concave down. A lot of different ways to analyze this. Choose whatever floats your boat or sinks your sub. Let's try another one. Example number 3. We have a cyclic function. It's repeating over and over again. I'm going to kind of ignore all this. Things are happening. What is the question asking? Which is true? I'm just going to underline. Which is true? Sometimes the question asks, what's false? What's true? This one is important. Which one is true? H is positive. H is positive. H is negative. H is negative. Again, every single time I see a single letter, ooh, I meant to cross out the letter. Every single time you see a single letter, you cross it off and say the height. H actually works for height there, doesn't it? Sometimes it's F, sometimes it's G, this times it's H. H is positive. Well, look at these Y values. You can't see where the X-axis is in this case, but you can look at these Y values and say, oh, well, these Y values all happen to be a mixture of positive and negative. So we need to analyze a little bit further. Oh, it's only talking about T1 and T2. Well, T1 and T2, T1 is F. Let me circle some important information. T1 is F. Let me label this one. This one is T1. And it says over here that G is T2. So let me circle that. That's important too. G is T2. Okay, so it's only talking between here and here. What's going on with our positive, with our heights being positive or negative? Well, look at these Y values. These Y values are both above 0. I mean, once you hit 0, you're at 0. But in between, look, it's parentheses. You're not actually at G. You're right before G. Everything here is above the X-axis. This dashed line is actually the X-axis. So we are above the X-axis, therefore we are positive. So you can cross off negative, cross off negative. It's not C, it's not D. Okay, we know we're positive. Are we increasing or are we decreasing? Remember, these words mean, are you going up or are you going down with the heights? Are heights going up or down? Well, these heights are going down, 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 down. If heights are going down, the correct answer is it's decreasing, therefore increasing is incorrect. The correct answer is B. Free response question 3 will always look like this example, almost always. You can look at the last 2 years, they always looked like this. Okay, look at example number 2. Describe how the rate of change, ooh, I see the words rate of change. What do? You cross it off and change it to the word slope. Describe how the slope is changing between T1 and T2. What is the slope doing between here and here? Is the slope changing? So is it getting bigger or is it getting smaller? Whenever the slope is changing, that means you have curvature. Curvature is talking about concavity, concave up or concave down. Is this a rainbow or is it a smiley face? There's my smiley face, right? Well, it's talking about this window right here. That is a rainbow. It is concave down, or you can see that this one is a cannonball. Gravity is pulling it back down to the earth. It does switch to being pulled up and pulling up and pulling up and switches to being concave up over here. Right now, gravity is pulling this down and pulling it down. Therefore, this is concave down. So you can say this one of two ways. The correct way of saying it is using their words, and you can say that the rate of change is decreasing. That is a super formal way of saying it. Or you can say that it's concave. Ooh, I can't write. Concave down. Oh my God, my writing. Concave down. Either of these two will give you full points. I like this one more because it refers to the words that are in the problem. The rate of change is decreasing, but these two mean the exact same thing. They are interchangeable. They are synonyms of one another. Let's try another. All right, where's T1 and T2? I know the pattern now. T1 is K. So let me come down here and say T1 is K. And T2 is P. This P right here is T2. So it's only talking about this interval on this line right here. Everything else I can ignore. All right, between T1 and T2, what's going on? H. Well, if I see a single letter, that's talking about height. Is the height positive? Well, look at these y values. Between -4 and -1, my height is negative. In fact, all of these numbers were negative, which means my x-axis roughly lives right about there. That's my x-axis. Everything on this entire graph is negative, which means it's not positive. It's between C and D. It's not A, it's not B. All right, between K and P, as I read from the left to the right, what is going on with my heights? My heights are going up, therefore I am increasing. Correct answer is increasing, it's not decreasing. Oh, but that's limited. It's increasing and not decreasing, therefore the correct answer is C. Now describe how the rate of change. Oh, I see the word rate of change. You swap that out for the word slope. Describe how the slope is changing. Well, I have to use their words, so I'm just going to start rephrasing. The rate of change, the ROC. The rate of change is it increasing or is it decreasing? Between K and P, I'm pulling it down, I'm pulling it down, I'm pulling it down. If I'm trying to pull it down, I am decreasing. Again, if you want to be super fancy, you can use a synonym for the rate of change is decreasing. You can say this is concave down. Again, using either of those two definitions where you say, well, the cannonball is being pulled down by the force of gravity, or you can say it's a rainbow. Whatever cutesy definition or formal definition that you want, there you go. Don't know what I hit there. All right, 2 more pages left. Let's do some more examples. All right, we've got a cool function up here. Let's just jump in and read example 5. Where do we have K negative? So again, the way that we interpret that, I see a single letter, that's height. Where is the height negative? Well, heights are negative everywhere on the bottom half of the graph. So I am immediately eliminating B and C. All of these letters are on the bottom half of the graph. And we're looking for decreasing. So if I'm decreasing, I must be going down. That's height down. If the height is going down, we are decreasing. So somewhere on the bottom half, where's the height going down? Well, the height here is going up. Where's the height going down? The height is going down here between D and E. And the height is going up between E and F. So if we're going between D and E, there's our right answer. It's C. All right, let's try example number 6. Which of these following is true? Remember, sometimes these questions ask which is false, so be careful of these words. And, I see the word rate of change. Immediately, what do? We cross it off and we say slope. Which of the following statements about the slope is true? And again, all of these don't say rate of change, they all say slope. Is the slope positive or is it negative? Okay, well, I have to say between A and B. Let's check. Between A and B, the slopes are all positive. The rate of change is positive. They said negative. Well, that is incorrect, therefore it's not A. Okay, let's look between B and C. Between B and C, the slopes are all positive. That's a positive slope. That's a positive slope. That's a positive slope. So it's a Dang it, they said negative. That's not it. It's not B. Let's look at C. The rate of change, slope, the slope is positive between D and E. Let's check. Between D and E, the slopes are all going down, therefore they're all negative. It's got to be by process of elimination. It's got to be D. Let's check. The rate of change, nope, cross it off. The slope is positive between E and F. Between E and F, yes, all these slopes are indeed positive. All right, let's do example 7. Again, we're doing the same thing. We're saying rate of change, cross it off, and we're doing slope. And we need to be true, not false. All right, so again, all these have rate of change. Swap that out for the word slope. Let's look between A and B. Between A to B, we are increasing, therefore the slope is positive. That slope is positive there. That slope is positive there. That slope is positive there. And, oh, whoa, words matter. This is talking about slope is negative. This is saying slope decreasing. They are not the same thing. This is saying that the slope is decreasing. Slope decreasing is the same thing. This and this put together means that we are concave down. If the slope is changing, then you have curvature. Curvature is talking about concavity. This says concave down between A and B. Let's look. A and B is concave up because it's a smiley face, or you can say that's an airplane trying to pull up, trying to pull up, trying to pull up. It's concave up. Not true. This one says that it's decreasing and trying to crash into the ground. What about this one? This one is saying that the slope is increasing. That means that it's concave up. So this one and this one put together makes concave up. Is it concave up? I don't know. Between B and C, let's go check it out. Between B and C, concave up means I'm pulling up. I'm pulling up. Well, no, this one is pulling down. It's pulling down. It's a rainbow. It's not a smiley face, so it's not B. Let's talk about C. This one is, again, talking about the slope increasing. Therefore, that's a concave up. It's the exact same words as before. Is it concave up between D and E? Let's check. Between D and E, is it concave up? It's trying to pull up. It's trying to pull up. That is the case. It is a smiley face. The correct answer here is C. Circle C. Therefore, by process of elimination, it's not D, but let's just check. The slope is decreasing, so that's concave down between E and F. Let's check. Between E and F, no, it's still pulling up. It's still pulling up. It's still pulling up. It's still a smiley face. All right, last example for this page. We still have one more page after this. Example number 8. On which of the following intervals is K increasing? So again, if you're seeing the single letter, K means height. Where is the height increasing? Increasing just means the height is going up, right? Where is the height increasing? And at the same time, concave down. So the height is going up, and we need to be concave down is this shape, where you're either pulling down by the force of gravity. It's a rainbow, whatever you're taking. We need both of them. So I'm looking for height is going up and concave down. Okay, height is going up, and I'm concave up. I need to be concave down. It's not that interval. Between, is B and C an option? B and C is an option. Is the height going up between B and C? Yes. Am I concave down between B and C? Yes, I'm pulling down by the force of gravity. So we have between B and C. That's the correct answer. Let's just check the rest of them. I need you to learn. Between C and D, what's happening? Between C and D, I am going down. My height is going down. We wanted our, where are we? I want my height to be going up. I want it to be increasing. Therefore, that one is incorrect. What about D? Between D and E. Between D and E, the height is going down. It's wrong for the exact same reason. I should be increasing. I should have a height that's going up here, but I'm going down here. Therefore, we're incorrect, and it's not D. We can cross it off. It was B. Last page. Here we go. On what intervals is F decreasing? Free response questions, no multiple choice. Okay, I'm going to do interval notation just to get this thing knocked out. We are decreasing whenever we are going down. Let me highlight that in a certain color. Let's just go with green. I am decreasing when the height is going down, and that happens between -1 and 2. So between -1 and 2. Always use parentheses here. There's no other spot, so I don't need to do a union with any other part. Now, next question. On what intervals am I doing two things? I need to be negative. Negative means that this F, I'm going to cross it out and say height. Where is my height negative? My height is negative only in this one spot. Everything else up here is either 0 or positive. And I need to be increasing. I am increasing because the height is going up. So everything between -5 and -3. from -5 to -3. All right, example 11, we have a new graph. We need to do two things. We need to be decreasing and concave up. Decreasing means that our height, this height, is going down, and we need to be concave up. Concave up means it's the smiley face, or your airplane is being pulled up, right? So height is going to be going down only, I'm going to highlight that range for me right now. Height is going down here, and then the height is going up, and height is going up on those two that I didn't highlight. So height is going down, check, right? And where am I concave up? Well, I'm concave down here. I'm being pulled down, so it's not there. And then right here, I appear to switch, and now I'm being pulled up, being pulled up, being pulled up. And I'm still being pulled up, but now I am not decreasing, I'm increasing. So this one interval right here is where I have both height going down and being concave up, a smiley face. So that's between -1 and 1. Between -1 and 1. And then finally, I need the rate of change. Ooh, I see the words rate of change. I cross it off and I change the word slope. Where is the slope positive? Okay, I'm going to do that first. I'm going to do this decreasing in a sec. Where's the slope positive? So let me go ahead and erase this. Where is the slope positive? I will re-highlight. The slope is positive there, and the slope is positive there. The slope is positive whenever this slope can be drawn positive. Now the slope is going down, so I can't say it's there. Slope is still going down. Now the slope is up. The slope is going up for each of those. So I've highlighted the first region, and I now need to have slope decreasing. Well, if the slope is changing, that's talking about curvature. Curvature means concavity. Slope decreasing means concave down. This one word right here in conjunction with slope means concave down. Where am I concave down? Let me re-highlight that in a different color and see where we have overlap. I'm concave down, rainbow there, and I'm concave down nowhere else. Where do we have overlap between our purple and our green? Only in this one interval between -5 and -3. So it's only between -5 and -3. All right, that does conclude the notes for topic 1.1. Let's go ahead and see all the pages. There's the last page, second last page. There they are, in all their glory. Thanks for watching.